the very next step in setting these things up, oh yeah, I'm going to add like 6 problems to what you did last night, so don't hand that in. We're just going to add to the homework questions, all right? So, just so you know. The next step, or set it down nicely. That was much nicer. Guys, come on. Really. I'm probably not gonna last much longer here, so I really need you just to let's roll through this together. Like I said, this probably won't take more than 15, 20 minutes to knock it out. You will have time, and most people are getting their stuff done before they get out of here, okay? What I was saying with this stuff is like the next natural step in the progression of doing the work. If you think about where we've come from, on 6.1 you were given the equation, cross multiply and solve. In 6.2 you were given the letters of the similarity stuff, of the equations. You then substitute in the numbers, cross multiply and solve. Today, you're going to be given the statement with the squiggly. You will have to write out the fractions in terms of the letters, then fill in the blanks, cross multiply and solve. So basically all we're doing is just adding one step what you've already done. It's the same thing all the way across. And once we get this stuff down, like I said, it's going to be really, really easy. So here's what we do. Whenever we have this similarity statement, think of it in terms of the two, you got a fraction on the, or excuse me, you've got a numerator to a denominator. Think of it as going from left to right. What I would do, and this is what I do every time, just to kind of ward off any of these silly mistakes, is that I would list out all of my side lengths. Because we know that if they're similar, the side lengths are going to be proportional. Angles we already know are going to be congruent. So the 3 side lengths you could get, AB, BC, and CA. And I know since that's on the left-hand side of the similarity statement, I throw them in the numerator. And now I do the exact same thing, put the letters on the right, and where do you think I'm going to put them? Yeah, on the denominator. So quite literally, now you are at what you did 2 days ago. You're given the letters, fill in the blanks. So you go to the diagram. Well, AB is 14. PQ was, I don't know. BC is 6, the other one's 9, 15, and 22 and a half. Cross multiply and solve. One of the things you can do, though, is you'll notice that you have 2 fractions that you can simplify. The 6/9 and the 15/22 and a half. If I simplify this one, what do you get? 2/3. So what's your scale factor? 2/3. Remember, the scale factor is the simplified ratio of a side. If I use that 2/3, it just makes the math a little bit easier. It's just smaller numbers. If I use 6/9, I still get the same answer. I just have to make sure I have a calculator. This one, when you see it as far as 2/3, well, you can do a little bit of quick mental math here. 2 times what is 14? 7. So what's 3 times 7? There's your answer. Cross multiply. 3 times 14 is 2 times x. We get 42. Oh, not 42, yeah. Then I get 21 for x. There's a couple ways to do it. Mentally or cross multiply and solve. And it works. So someone's about to steal that. So, as I said, as long as you know that you've got the similarity statement, this step here, where you write down everything, it takes an extra minute or 2 of your time, but it forces you to fill in the blanks, and it becomes so fast, all right? It's how these things are easily solved. Excuse me. Oh, thank you. Same deal. Actually, let's do the other. Let's do this one. Get ahead here a little bit. No, I'll go back. I need this one first. So again, we have a similarity statement of triangles. RST is similar to XYZ. It asks us to find the scale factor and then find the missing sideline. So, excuse me, I saw there were a bunch of markers. I grabbed them before. Do you guys still have those? Oh, they were before. You stole them, didn't you? Sticky fingers. Why'd you steal markers? What's that? You stole them. Draw on the desk. A picture. Christmas card. What's that? What, make a Christmas card?
Should I bring it next time? I think just write all over this stuff.
So again, first thing I do is I just write it out. RS, ST, TR. I go from there. The place with the thing and the stuff.
Yeah.
You write out the other one. Remember, all I'm doing is just taking it right off the letters. Just exactly the same way that we talked about side lengths being congruent when you had congruent triangles. Here, the difference is that they have a ratio as opposed to equal. Right. Fill in the blanks. Let's see, 45. ST is 27. Never mind. There's A, 50, 30, 40. So 45 over 50, what does that simplify to? 9/10. Hey, does 27 over 30 simplify to the exact same thing? So what's your scale factor? 9/10. Now, what we did here is we're finding the scale factor going from left to right. Yes. We're finding the scale factor going from left to right. It asked us to find that. What happens if it asked you to say XYZ to RST? What would your scale factor be? What's that? Yeah. You just flip it. Okay? If it's saying to go the other way, it'd just be 10 over 9. That's all. So use your scale factor to solve for the missing sideline. Cross multiply and solve. Or 10 times what is 40? What's 9 times 4? 9 times 4? 36. You still get 36. There's your missing side. Okay. What? I don't know. Here's the other one little new part about today. We just found a second ago that this side was what, 36?
Yep.
Okay. We knew that the scale factor going from left to right was 9 over 10. That was our scale factor. What's the perimeter of the triangle over on the left? What's 45, 36, and 27 when you add that up? How much? So the perimeter of triangle, this is what, 108?
Yes.
What's the perimeter of the one on the right? 30, 50, and 40 adds up to equal 120. Hey, what does 108 over 120 simplify to be? What? So the perimeter has the same ratio as sides? Shut up. Why are you being sarcastic to me? I don't feel well. I'm going to leave that alone. Here's the big thing. The scale factor of sides is same as of the perimeter. Sides and perimeters have the exact same scale factor, right? Because of the relationship. This perimeter is made up of sides. Convenient. The reason why we use this is because we eventually you'll be able to find perimeters of similar figures if you just know one side. You don't have to know all of them. You can do it using scale factor. Let me show you an example of that. Are we okay with that? What? That's not what I heard. Look at this example here. We only have 2 more examples, so roll with me here, guys. In this case here, we have 2 quadrilaterals. Quadrilaterals, 4-sided polygon. It tells you that they are similar. A, B, C, D, and F, G, H, J. Those 2 are similar to one another. All the angles would, or all the corresponding angles would be the same, and all the sides are proportional. So, just like we've done in the past, what you want to do to start with, list the sides. Write out the 4 fractions that you could create and fill in the blanks. Okay? That's what a similarity statement allows you to do. It allows you to take some information given to you here and translate that into something that is workable. That means that you have AB it allows you to create something workable, something easier to use. Okay? What's that? Idea. It's not that important, I guess. So once you have that that's workable, that's when you start to put stuff in and you fill in the blanks. So if I start filling in the blanks, since I don't know what these sides are here, I'm just going to call them X, Y, and Z. Okay? Come on, guys. And just go through the object. 15, 8, 10, 12. X, Y, Z, 8. Convenient. We have one of them that works. So if I use the one fraction that works, what does that give me for a scale factor? The way I have it written, I'm going from left to right. This is scale factor of 3 over 2, sorry. But the question was, what's the scale factor going from right to left? So what would I do to that scale factor to give the right answer? Just flip it. Yeah, just flip it. Remember, a lot of times, the goofiest thing that you're going to find is that the diagrams are generally, when you write out a scale factor, more often than not, you're going to go ahead and write that like you would reading, left to right. Stuff on the left is the numerator, stuff on the right is the denominator. It's just your brain winds up being more wired that way. It's an easy way to remember it. But then go back and read what the question says. This question says, hey, knucklehead, it wants it going from right to left, so it means you have to remember what you did. You write down your answer, and flip it. Now, there's one of two things you can do. It asks you to find the perimeter of the smaller object. You have this new scale factor, 3 over 2, which means you could use that, solve that, solve that, solve that, or use it to solve it with the perimeter right away. Since you have all 4 of these, what's 12 and 8? 20. 20 and 25 is 45. Cross multiply and solve. It's quicker. The reason why they do the perimeter stuff with this is so that way you don't have to do cross multiplying 3 times. They'll actually just do it once. Okay. So what's 2 times 45? Divided by 3, what do you get? 3. That's why it worked. That's why you can do that. You could go ahead and cross multiply it out and get each individual side if you want, or if they ask you to. But if you're just asking for perimeter, just set it up. Not too scary? Now, what if they put in something like this? And they ask you, let's say they tell you that that's 18. And they want to know if it's 18 from B to D, what would be the corresponding diagonal in the other one? What would be the corresponding diagonal? Let's look at the lettering. If I went from B to D, what would it be? G to J. Those would be corresponding diagonals, right? Do you think they have the exact same scale factor? Yes. Because it's still a corresponding part within the figure. So you can do the exact same thing. You see this a lot with these with similar figures. They will put in there a diagonal. They will put in there what's called an altitude. An altitude is something drawn from a vertex that's perpendicular to a side. They do it, eventually we'll show you how this works with mid-segments and stuff like that as well. But that's kind of what we're getting at here, guys. If you take the time, write down the fractions via the letters, fill in the blanks, cross multiply and solve. It is quite literally one more step than what you did yesterday. That's all. I think you'll be okay. Me? Wouldn't that be like afternoon cool then? What would night cool and day cool mixed together be? Would that be dusk quill?
That'd be. How do you think together?
Is it dusk quill or is it? Is it dusk quill or is it like? Yeah, well isn't dusk and evening kind of same thing?
Yeah.
Or is it dawn quill?
That's morning.
You said that that's an overdose.
I said that like 10 times.
I can't hear anything. You think
Look
I'm?
at the original.
Jeez. All right. Do these. Same. What page was that? Page 376. Do these. Give me a second. I'll post some of them up here so you guys can get started if you don't have your Chromebooks. Yes, ma'am. I'm sorry, what's that? Yes, exactly. Fill in the blanks. That's it. Well, you have it here. You were given this. CB is 6. You know what BA is. That's 4 and that's 7. Fill everything in, cross multiply, divide out, you're done.
Oh, okay.
It's okay. Yeah, no, that's fine. You'll get you're going to get decimals from time to time.
Oh, so it's okay. Oh, I remember last time you said something about fractions.
But I'm like, I know it.
Yeah, you're going to get them. All right. Let's redo this one real quick.
It's just like it's the one thing you do. Okay, I have another question.
1 second, let me put this in here real quick and I'll help you out. All right, guys, here's your problem so you can get started. If you don't have your Chromebook, you can look up at the board.